Here we go.
Wait, it's for Miss Clark.
No, it's for me, for subbing for her all this week. Okay, so objectives, announcements, listen up. Today, we're going to revisit what we've been doing for the last 2 days, which is using these things called there's no talking while I'm talking. This ain't computer science. When I'm talking, you're not. Use indefinite integrals with common integrals and polynomials, right? So we've been doing that for a while, like how to take integrals of basic stuff, right? But 2 new ones for today, the double block. So double the objectives. Specific antiderivatives given in initial value. So we're going to learn something called initial value problems today. And we're going to use U substitution, which is another technique for integration. We're going to learn both of those today. Normally we would spread that out by a little bit more, but I'm feeling feisty, so we're going to go double today. All right. So announcements. I mentioned this before. We're going to have a memorization quiz on Monday. I realized I didn't give the people who were not here the previous day the things to memorize. But the weekend should be plenty of time for that. I'll give you that today if you guys were people that were missed class on Tuesday. Okay, and we'll talk about what that is a little later. All right, so the docket, which for all you juniors is the same thing as an agenda, but it's always on the SATs, so I always use docket instead of agenda. So when it does show up in the SAT, you'll be like, thank you, Mr. Caden, you got me into college. All right, so we'll start by going over that do now we just looked at. Then we will look at the homework. We'll learn something called initial value problems. Then we'll learn something called U substitution. And then we'll do MAD practice yo, which basically means your homework. Okay, so let's go to this do now and walk through this a bit at a time and make sure that we're still on track with the stuff that we've learned previous to today. So we have learned quite a bit. I think we learned a little bit up till now. Yeah, pretty quick. AP Calc's a fast-moving course. Who feels like, all right, so the way we're going to do this is I'm going to click once for each problem, and you guys I'm going to ask you whether it's legit or illegit, the thing I write up there. Okay, ready? Is this legit or illegit? Legit? All right, somebody raise their hand and argue one way or the other. Maishka?
It's correct because you said that when we have like a constant in the front, you can take it out.
Yep.
And do the integral of the
Stuff that's left. Right?
yeah.
Yeah, so it's okay if you have a constant out front, like 4 or -4. You can pull it out for the integral. You don't have to do it that way, okay? But you can do that. Is everybody comfy with that? We learned that the other day. Okay, it's the same with derivatives, actually, if you didn't know. All right, what is the integral of cosine, scholars?
Sine.
Sine. So that's your answer, right?
Let's see.
Good catch, good catch. Okay. Any questions? All right, I can't remember whether on the top right or the top left, but either way, take a moment to observe this and tell me if this is legit or not legit. Legit. It's the same as what we just said, right? You can pull constants out front. And again, you don't have to, but that 9 can be pulled right out of the integral. Questions? All right, what is the integral of secant squared of x? Everybody? Right, so that don't forget your plus c's. Okay. All right, next. What's up with this? Oh, whoa. I don't know what that's about. Oh, I screwed up. Ignore that. But you can't ignore it, so just ignore it. All right, legit or not legit? Right, a square root becomes a 1/2 in the exponent, right? So we already have the 7, now we have 7/2. What's up? Everybody else show up to second class? Who's this from?
I mean, she's not there anymore.
Yeah. Let's go into my personal pocket. Okay, so which one of you elite scholars can finish this up for me on their own? Somebody from not the front row, huh? Livy.
So you add 1 to 7 over 2.
Which is what? Everybody.
9.
9 halves. So how many halves are in 1? 2. How many halves do you have right now?
7.
So how many halves is 1 plus 7 halves? 9 halves. Okay.
So then you you divide 5 by that, which is the same as multiplying it by 2 over 9.
Correct.
Which is 10 over 9.
Right. You need your plus C. Other than that, it's perfect. Any questions?
No.
Who's 3 for 3 right now? I don't care. You guys are bragging. Okay. Shh. I don't like this rumbling. The only rumbling should be in my tumbling as I wait to eat this Twix in front of you. Yes, Maishka.
What if you took out the 5?
That's totally fine, but you should still get the same answer in the end. That's totally fine. Okay, raise your hand if you think you're good at fractions. Liars. Okay? All right. Next, legit or not legit? Take a moment to think at it. All right, legit or not legit? That is legit. Okay? There's two things going on here. First of all, if you have two things being added or subtracted inside the integral, it is legit to separate it into two separate integrals. You with me on that?
Yeah.
Is that legit if they're being multiplied?
No.
Is that legit if they're being divided?
No.
Is that legit if they're compositions of functions? You know what that means?
No.
Yeah.
It's like a situation where you use the chain rule in derivatives. The answer is no. We're going to learn how to do that today.
Oh.
Wait, hold on.
Okay. What's up? All right. Shh. Okay. What's the integral of 12, everybody? 12x. Of course, we have our little plus c, which we're going to get to in a second. The minus sticks around. What's the integral of just x cubed?
1/4 x to the 4th.
Okay, and then our 3/4 hangs out, which gives us 12x minus 3/16 x to the 4th plus c. Who's going to call out who's the boss right now? Who can see an error I made? Any?
Let me see this in bottom. Okay, so wouldn't you do, if you divide, you have to divide 3 by that fraction, so you flip it, so it'd be 3/4 times.
Nope, these are being multiplied. So the fraction, I pulled it out in the beginning, right?
Oh, you
So
have to,
the 4 comes down here. This is correct, and the answer that you see here is correct, but I made a mistake earlier. Somebody else besides Maisha, I'm getting tired of her voice. John?
There's no C.
Yeah, I'm missing a plus c right there. So we're going to get out my pencil and do some excellent work. Right? At this point, at this step, I have taken the integral, right? So there should be a plus c right there,
it's
that's all.
just your work.
Hmm?
Oh.
Yeah, technically.
Technically, we just don't have it there.
I would put it there, right? Just in case. Once there are no integral symbols in your problem, then you should probably have the plus c there. Does that make sense? It's better to do it as you go, that way you won't forget, you know? Any questions on all 4 of those? Any of the 4? Who got all 4 of them right? I thought we learned we're not supposed to put our hands up for questions like that. Okay. It's fine, you can keep bragging. I'm down. All right, so raise your hand again if you did the homework. Raise your hand and hold it up. Hi, come on, with pride. You spent all this time on this homework.
50% of it.
Right? MJB lied to me earlier today. That's what's crazy. Oh, you just didn't put your hand up. Okay, so let's look at the front of the homework.
MJB.
MJ.
Here we have. So everybody get that homework out. All right, there's a little bit too much mumbling. I'm not into it.
Oh, and
Okay, we're gonna go through all these and again do my legit, not legit. Okay, so the first one right there, the integral of 4 dx is equal to 4x plus c. Legit or not legit?
Legit.
Shannon, give me a sentence explaining why that's cool. What's the rule that's sort of being applied here? Is what? You slap an X on it. That's exactly right. Did anybody write that in that box? Bonus points.
Oh, really?
Okay. Next one. Here I have the integral of negative cosine x dx is equal to negative the integral cosine x. Is that good or no good?
Legit.
Legit. Somebody else, we've talked about this too many times already before, right? You can pull constants out, right? And a negative is just like any other constant. It's just like -1. So we can pull that out, no prob. All right, next one. Legit or not legit? All right, same story. The 5 can get pulled out. I'm getting tired of this, Caden. Let's do something interesting. Ooh, this is my favorite one. Legit or not legit? Raise your hand if you think or you thought this one is legit. Raise your hand if you think this one is not legit. Raise your hand if you don't have the guts to raise your hand. Right, okay. Let's break this down. Let's break this down. Let's break this down. So, I have the integral of 4x squared plus 2x plus 4 dx. All right? So first of all, would you guys all at least agree that I can bring the integral to all 3 of these individual guys?
Yeah.
All right, so let's do that. 4x squared dx plus the integral of 2x dx plus the integral of 4 dx. Okay. Are we happy with this so far? Okay. True or true or false? Or legit or not legit? This, the 4x squared integral you see here, and this, the first term over here, are equivalent?
Yeah.
They are, because you can pull the 4 out. Come on, that's like 9th exercise of that. All right, the next one, same story, right? We have the 2x here, and I pulled the 2 out, just like that, right? So we're happy on that. And then what's the integral of 4?
4x.
There you go. So is it legit or not legit? Legit. The plus c might have made it a little confusing because it's there, and there's still integrals there, so that might have been kind of confusing, but I think it's legit.
Wait, can we?
You want to do that again?
Yeah.
So let's make sure we're quiet while other people are asking questions. Anyway, you go on this. Go from here to there. What's that?
Is that on the paper?
So this is the original problem on the left side, right?
Yeah.
And then this, I've just split that up into 3 separate integrals, right? Because they're all being added, so you can do them individually,
Yeah.
right? Okay. This is the same as 4 times the integral of x squared dx. This is the integral of 2x dx. And I'm just pulling these constants out. And the last one, the integral of 4, is 4x plus c. See me? Okay. If the plus c was not there, would this be legit?
But you took the integral.
You did, but as long as you get a plus c when you take these ones, it would be good enough for me. I don't think anybody would mark off points for this until all the integrals are gone and there wasn't a c, you know what I mean? But I'd say it's legit either way. All right, next one. You can impersonate me all you want. Still not going to get a good grade in this class. This one says, you're on camera and audio and everything. I can't even cover up for this report. It was close. Good work. All right, the integral of sine x times cosine x. What does this say? Not equals integral of sine x plus cosine x. So is that legit or not?
Legit.
That statement is legit because if it said equals, it would be illegit, and it doesn't say equals, it says regular. It does not equal, right? So the left side of that, the two things being multiplied, does not equal the right side, and so that statement is legit, right? That's that standardized test type mentality junk getting in your head, right? It's like we're not actually going to quiz you on whether you know the topic. We're just going to quiz you on whether or not you're smart enough to understand the does not equal part, right? And by smart enough, I mean like paying enough attention. Okay, tricky one. We have little f of x is 4x squared plus 2x, and big f of x is 4/3 x cubed plus x squared plus c. Is that true?
No.
Raise your hand if you think it's legit. Raise your hand if you think it's not legit. So why do you think it's not legit? Because the c is there? Interesting, right? Interesting. So.
Symbol.
All right. So how can somebody look back in their notes? Who takes meticulous notes? What is the definition of an antiderivative? Okay.
F of x is a uniform function.
Whose derivative is?
F of x.
Derivative is f of x.
Right. So an antiderivative is defined as a function whose derivative is the original function, right? So what's the derivative of this? Is it that? As long as c is a constant. So I would say this is legit. That's kind of a bad question, though. Don't worry about that one. If you got that wrong, don't worry about it. I'm not trying to trick you at that level, and neither will they. Okay. Okay, this one says negative secant squared of x dx equals negative, the integral of negative secant squared of x dx is equal to negative tan of x plus c. Legit or not legit?
Legit.
Okay, legit. This is fine. I was just trying to confuse you about negatives and these weird sines and cosines and all that. If you pull the negative out, right, you're left with the integral of secant squared of x on the inside, right? And so what's the integral of secant squared? Tan, and we had that negative chilling outside. Any questions on any of those? 1 second, Louis. I know. It goes on the website. All right. So that's what C means. Okay. So a function has an infinite set of antiderivatives. So we can again shift the graph up or down, and we'll still have the same derivative. That's what plus C means. Okay. So sometimes on the AP exam, on a test for meter sparse or whatever, okay, they might ask you to solve for a specific antiderivative. They might not. They might want one of those infinite set of antiderivatives. They may say, I want that one. Okay? And it's going to be your job to figure out which one it is. So to do that, to specify one, and you don't have to write any of this, guys. Don't write all this junk down. This is just rhetoric. Okay? To do that, you're going to need a specific piece of information that's going to help you to specify one of the various functions. Right? So there could be a bajillion of them, and they're going to give you some piece of information that's going to